In this lesson, we are going to be talking about describing function transformations. And in this case, we're going to focus on dilations. I'm going to call it dilations, but you'll get a better idea of what that means as we go through this lesson. So how are we going to do it? We're going to always start by explaining what we mean. What are transformations? We need to explain that so you understand why we're doing that. We're going to explain dilations, vertical and horizontal stretch and compression. You'll get a better idea of what all of that stuff means once we get into it. And then we'll talk about the technique for expressing dilations and then learn how to express dilations in function notation. And then right after that, we'll do some examples together where we're expressing in function notation, and then we're taking function notation and then express it and describe it in words. So now, what is a function transformation? One of the interesting things about math is sometimes you can actually guess what it means by just knowing what that word means. To transform means to change. So a function transformation is to change the function. And we're going to use, in this case, we're going to use dilation to figure out how the function changes. So what are dilations? Dilation is stretching or compressing a function horizontally or vertically. In the general sense, especially if you're learning geometry and if you're learning functions in geometry, this topic we're dealing with is functions as it relates to algebra. But when you're dealing with dilations simply means to make bigger or to make smaller. And we do it with the same ratio. So when you make a shape bigger, all of the components of the shape are going to get bigger with the same with the same scale factor. And if you're making it smaller, it's going to also have the same scale factor. So now let's bring this back to algebra. So vertical dilations represent dilations with respect to the vertical axis. Let me just write here that this means to make bigger or smaller. So vertical dilations are with respect to the vertical axis, which is your y-axis, and then horizontal dilations are with respect to your x-axis, which is right here, or we call it your horizontal axis. So the main forms of dilation are your stretch, which is to make bigger. Sometimes you can look at a stretch. If you had a rubber band and you stretch it out, you can see that it just doesn't make it bigger, it makes it longer. And if you compress, it makes it shorter, if for lack of a better word. So it makes it smaller, it makes it bigger. So we'll do some examples. So what is a horizontal dilation? The dilations happen with the input of the function, and like I said earlier, like you should know if you have watched some of the other videos on transformations, when it comes to the horizontal axis, it tends to behave a lot more different. It behaves differently from the way you would normally expect it to behave. So for example, if I have f of x is being transformed to f of ax, this represents a horizontal dilation of factor 1 over a. So let's see what that means. So when a is greater than 1, this becomes a horizontal compression. So for example, if you have something like f of 2x, this actually, you would think it's getting bigger, but it actually is a compression. It's a horizontal compression. And if you had a fraction, so let's go with something like f of 1 over 3x, this actually is a horizontal stretch. So just think about it as it behaves in the opposite way. Now let's spend some time talking about vertical reflections. So vertical reflections always happen with the output of the function. So here we're actually referring to a reflection. So there's a vertical reflection. So if you have f of x being transformed to a f of x, it represents a vertical dilation with a factor of a. So if a is greater than 1, you're going to have a vertical stretch. But if a is between 0 and 1, which is simply means that a is less than 1 here, we're going to have a vertical compression. So let's see how we can put all of this stuff that we have covered. Let's put it to practice using some examples. Express this transformation in function notation. So here, we're going to do a few things here. So we have f of x to a f of x. We have a vertical dilation, and the factor is a. If we have f of x to f of ax, we have a horizontal dilation. Factor is 1 over a. Okay, so let's go ahead and try to answer this. F of x is stretched horizontally by a factor of 4. Is stretched horizontally by a factor of 4. So if the factor is 4, then we're going to have f of x to, remember when you have a horizontal, any form of horizontal dilation, you are always dealing with, you're going to be dealing with a fraction as your context. So this is going to be f of, if the factor is 4, it's going to be 1 over 4x. So this is going to be a horizontal stretch by a factor of 4. Next example, f of x is compressed vertically by a factor of 2. It's going to be a factor of 1 over 2 if it's a vertical compression. So it's going to be f of x to 1 over 2 f of x. So this is a vertical compression. F of x is compressed vertically by a factor of 2 and horizontally by a factor of 3. So vertical compression by a factor of 2. So we're going to go f of x is going to be 2 because it's a vertical, it's a vertical compression. If it's a vertical compression, then we're going to have a fraction. A vertical compression, that is 1 over 2 f of x, and also horizontally compressed by a factor of 3. So let's do that right here. Let's make this right. So this is going to be a horizontal compression is going to be 3x. So a vertical compression is going to be a fraction. A horizontal compression is going to be a whole number. So that's the only difference in the way this works. So let's do some examples here. Describe the function represented by f of 4x. So we're going to be seeing what we call a horizontal compression. Horizontal compression factor is 1 over a, so it's 1 over 4. Describe the function represented by this. So this is going to be a vertical because your dilation factor is outside the function. So it's going to be a vertical stretch, and we're going to have factor of 7. And lastly, describe the function represented by 1/3 f of 5x. So we're going to have a vertical compression. So we have a vertical compression, and we have factor is 1/3, and then we also have a horizontal compression, and the factor is always 1 over a. The factor is 1 over 5. So this is how you will describe any form of dilation. Dilation means we're stretching or we're compressing. And when we stretch on the vertical axis, we have a whole number. When we compress on the vertical axis, we have a fraction. The reverse is true for horizontal axis. When we compress on the horizontal axis, we have a whole number. When we stretch on the horizontal axis, we have a fraction.